So, hi, I'm Karamarie Fecho. I'll be speaking to you, as was introduced, about RoboCop today, which stands for Reasoning Over Biomedical Objects Linked to Knowledge-Oriented Pathways. RoboCop is an open source knowledge graph system that I've been collaboratively developing with folks at the Renaissance Computing Institute, or RENCI, at UNC Chapel Hill for several years now. RoboCop is jointly funded by NIEHS and the NIH Office of Data Science Strategy. The prototype was developed by NCATS. It's a relatively new resource that is currently being moved from a prototype to a production level resource. Next slide. I'm controlling the slides.
Hang on a second.
It's her slides. She should move it.
Where there's no.
She moves it.
Oh.
I think you can advance your slide yourself, Karamarie. I don't know if you can hear me.
Me?
Yeah, try
Try
yourself. Yeah.
Okay, you got it.
Okay, so I'm controlling. Okay. So Julia did a great job introducing knowledge graphs earlier. Knowledge graphs are in ubiquitous use today, not only in search engines such as Google, but in a variety of applications, several of which are listed here. As was mentioned earlier, the basic unit of knowledge in a knowledge graph is the subject, predicate, object triple. Numerous challenges exist to the creation of knowledge graphs, however. For instance, while there are many schemas, data models, and technologies to support biomedical knowledge graphs, there's a lack of standards across the biomedical research community. Moreover, there are multiple ontologies and identifier systems for the same or similar biomedical concepts. Additionally, there are disparate and overlapping terminologies and vocabularies. And finally, there are a variety of approaches for modeling basic biomedical concepts, such as chemical versus chemical exposure. RoboCop has adopted several approaches for overcoming these challenges, ones that we believe will help to ensure long-term sustainability. One key decision was to adopt BioLink model. BioLink model essentially leverages controlled vocabularies and ontologies to create a graph data model and upper-level ontology that supports semantic harmonization across disparate biomedical data sets and ontologies. The model expresses domain knowledge as an hierarchical graph of relationships between biomedical entities. The example on the right shows a small branch of the BioLink hierarchical tree. The link in the right corner provides full tree visualizations of BioLink subjects, or categories, and predicates. BioLink's development was largely driven by the NCATS Biomedical Data Translator Program, and the model has since been adopted by several other large-scale consortia, such as the Monarch Initiative and the Illuminating the Druggable Genome Initiative. Core to BioLink model is the concept of association, shown here as an onion diagram. At the heart of an association is the basic unit of knowledge in a knowledge graph, which is the subject, predicate, object triple. Qualifiers and property slots can be added to model more nuanced assertions and create a statement, which itself can be qualified. So this shows you an example where you might imagine the core subject to be dioxin with a qualifier of in drinking water, the core object being cancer with a qualifier of the prostate, and the predicate being causes with a qualifier of with long-term exposure, thus forming the fully qualified statement, dioxin in drinking water causes with long-term exposure cancer of the prostate. In addition to BioLink model, and as part of the Translator program, we've invested significant time in the development of powerful tools to support name and identifier resolution, which anyone who's worked with knowledge graphs knows represent significant challenges to the integration of data. Two key tools are Name Resolver and Node Normalizer, both of which can be accessed programmatically via open APIs. Name Resolver takes lexical strings and attempts to map them to identifiers from a vocabulary or ontology. In this example, the input is clofibrate. Node Normalizer takes an identifier and returns the BioLink preferred identifier, all other equivalent identifiers, and the BioLink semantic type for the entity. The example here is for KEBI 3750, which is the identifier for clofibrate. Okay, so what is RoboCop exactly? Well, RoboCop is an open, modular, flexible knowledge graph system comprised of several key components, several of which are listed on the left here. Orion, or operational routine for the ingest and output of networks, is a custom software pipeline that leverages BioLink model and tools such as Node Normalizer to ingest RoboCop's underlying knowledge sources, semantically harmonize them, and output them as a collection of automatic knowledge graphs that are all interoperable, including the RoboCop knowledge graph, which can be accessed by a front-end user interface or independently from an automatic page, which I'll show you in a second. RoboCop also contains a variety of supporting tools and technologies, such as enrichment functions. The RoboCop knowledge graph currently contains about 10 million nodes and 140 million edges drawn from more than 40 biomedical data sources and biontologies such as gene ontology, Mondo, KEBI, and CTD. Again, RoboCop leverages BioLink model for semantic harmonization and tools such as Node Normalizer and Name Resolver for identifier resolution. The RoboCop knowledge graph can be queried via the RoboCop user interface. Shown here is a partial screenshot of the main landing page at robocop.renc.org, which is openly accessible. The blue button on the landing page takes users to the RoboCop question builder. The purple button on the right takes users to the RoboCop automatic collection of interoperable underlying knowledge sources. Here is a screenshot of the RoboCop question builder tool. Here, users can build a query graph using the fields on the left or the bubble graph on the right. Users can also click an About button, a how-to guide to learn more about the question builder, access a tutorial, and submit a help ticket, explore preloaded sample queries, or upload your own query in JSON format. After clicking the Submit a Query button, the user will be taken to the RoboCop Answer Explorer tool, which I'll show you when reviewing an example application. Clicking on the purple button from the main landing page takes you to the RoboCop automatic collection of harmonized and interoperable knowledge graphs, including the RoboCop knowledge graph and its underlying knowledge sources. For each of these knowledge graphs, there's a brief natural language description, as well as live statistics on the number of nodes and edges, the current version, and other metadata. Here, one can directly query RoboCop KG independent of the question builder by submitting a Cipher query and through various other API endpoints. Okay, so I thought I'd show you just an example application of how this all works in practice, as example applications and real-world scientific drivers are critical for sustainability. So in this example, it's specifically focused on an adverse outcome pathway, or AOP, exploring biological mechanisms linking a chemical exposure to liver toxicity. This use case was presented to the RoboCop team by an investigator within the Division of Translational Toxicology at NIEHS. The specific question was asked is, can we use RoboCop to suggest an AOP to explain the relationship between clofibrate or clofibric acid, an environmental hazard and activator of PPAR alpha, and hepatic fibrosis? We framed the use case in the context of a conceptual pathogenic model of hepatic fibrosis that was developed by Kim and Lee. In brief, the authors proposed a multiple parallel hit model that is framed as an adverse outcome pathway and asserts that environmental exposures and or metabolic factors increase free fatty acids, which activate PPAR alpha or peroxisome proliferator activated receptor alpha, and liver metabolites and hepatocytes, leading to hepatic injury, which then stimulates an inflammatory response in Kupffer cells and a fibrotic response in hepatic stellate cells, leading to hepatic fibrosis. We hypothesize that the activation of PPAR alpha by clofibrate is related to hepatic fibrosis. We aim to apply RoboCop to substantiate our hypothesis by replicating the basic features of the pathogenic model of hepatic fibrosis put forward by Kim and Lee and extending the model to the PPAR alpha activator, clofibrate. So we then used RoboCop to generate an AOP that sought genes, proteins, and biological processes or activities linking clofibrate to hepatic fibrosis. Shown here is an example answer subgraph as displayed in the RoboCop Answer Explorer. As an answer subgraph, the AOP is not linear, but generally asserts that clofibrate increases the expression of PPAR alpha, which is actively involved in the cellular response to lipid, which involves CCL2, which is genetically associated with hepatic fibrosis. I want to mention a few things. First, the clofibrate PPAR alpha edge was important to establish given that clofibrate is a known PPAR alpha activator. In this case, 13 knowledge sources contributed edges, including the highlighted edge that was contributed by CTD and included 12 supporting publications. Second, the answer subgraph contained a number of occurs together in literature with edges. These edges were not part of the original query, but rather were added by Omnicore, which is a Robocop service that is built off of a graph database of PubMed entity co-occurrences and abstracts. The Omnicore edges not only provide users with supporting evidence, but they are used with publications provided by curated knowledge sources such as CTD to score and rank answers. Several additional edges are highlighted in this example, including edges that were contributed by HelioNet and Dysgenet. So when we consider Robocop's AOP application in terms of replicating the basic features of the pathogenic model of hepatic fibrosis put forward by Kim and Lee and extending the model to the PPAR alpha activator clofibrate, a few things stand out. First, as shown in green circles, Robocop was able to replicate basic biological events, including chemical exposures, free fatty acids, PPAR alpha, lipid metabolism, cytokines and chemokines such as CCL2 and other inflammatory processes. However, shown in red circles, Robocop was unable to replicate contextual aspects of the model, such as cell types and anatomical entities. To address this, we're looking for other data sources, such as cell-to-cell interaction database that may be able to fill in some of these contextual gaps. So moving back towards sustainability, we, as any federally funded project, recognize the need to develop and implement a long-term sustainability plan independent of federal funding. This is true not just of Robocop, but of all sorts of federally funded knowledge graphs and knowledge graph systems. The adoption of BioLink model as a community-driven established data model and universal graph schema represents a key step towards sustainability. The investments we've made in tools such as Node Normalizer and Name Resolver and data harmonization pipelines such as Orion will also help to ensure sustainability. However, one critical factor for sustainability that was not yet firmly established is the need to create an active and engaged community of practice specific to Robocop, but also more generally in support of a unified vision and plan for biomedical knowledge graph sustainability independent of federal funding. One approach that we're considering is an Ambassadors and Champions program. This is a program that was developed by the Center for Scientific Collaboration and Community Engagement, and it's been adopted by the National Microbiome Data Collaborative, where it's proven to be highly successful. As part of the Translator program, we recently launched an Ambassadors and Champions program specific to Translator. I'm leading that particular program. In this program, the Translator ambassadors are being recruited as clinical and translational scientists from any career stage. They're brought in to work on short-term scientific projects and use the Translator UI in support of their research. Technical champions are primarily data scientists and developers who are being recruited to engage with the Translator Consortium, but through the Translator backend primarily. And their goals are to advance their technical skills and in contribution to the Translator UI. Participants in the program enroll voluntarily and they're not compensated. However, we do offer travel support to attend one meeting or conference within their field with the goal of highlighting their Translator project. So the idea is that we would bring in these ambassadors and champions, engage them with the Translator Consortium, and then they would go out and spread the word about Translator by highlighting their particular projects to their peer communities. The Translator Ambassadors and Champions program was officially launched in June, but early signs have demonstrated its potential. For example, we were able to fill the slots for the initial cohort very quickly and with very little effort, with a pretty even balance of ambassadors and champions without particularly trying to evenly recruit ambassadors and champions. The Robocop team is monitoring the Translator program and will adopt a similar program later this year should the Translator program continue to demonstrate success. And with that, I'll close by acknowledging the RoboCop team, a few members of which are listed here, as well as our funders. Please feel free to reach out to me by email if you have any questions or want to learn more about RoboCop. And I thank you for your time.
Thank you so much, Karamarie. Just one question over here.
Thank you. I think the ambassador program is very interesting, and I'm just wondering what are some of the incentives, kind of the implicit incentives for the, say, translational science ambassadors? What are they interested in getting out of it?
So a lot of it is networking, I think, and engagement with the Translator Consortium. Of course, travel support doesn't hurt. The time commitments are very flexible, so we're allowing folks to just spend as much or as little time as they can, with a certain amount of commitment expected there. Most of the ones that we have people from every career stage. We didn't target anyone specifically for recruitment. So I found that interesting myself. And they get a concrete little project out of it. We also, in certain cases, offer like co-authorship on translator publications that come out, whether they're just internal publications or peer-reviewed publications when it's appropriate. I think there's depending on the career stage, there's like swag that we offer for folks that are maybe more junior, probably not as incentivating for more senior ambassadors. But so far, like I said, it's an early program, so we don't exactly know how it's going to go, but it seems to be, it's been really easy to recruit people. So that's a really promising sign. And so far, everyone seems pretty enthusiastic about the program.
Thank you so much,
You have to
Karamarie.
stop sharing.
Yeah.
After that, then you can use this.